So I got this comment earlier, and here we go. This is an integral that requires a lot of algebra. First, we will have to do polynomial long division. Second, we actually have to complete the square for the denominator. So let's see how we can do it. First, though, when we have a rational function here, to integrate that, we have to make sure the degree on the top has to be lower than the degree on the bottom. But this is not the case because this is 3, this is 2. So we will have to do polynomial long division. And this is how we can do it. Go ahead, draw the long division symbol, and then put the top inside. 2x cubed plus 9x squared plus 30x plus 11. And then put the bottom on the outside, x squared plus 4x plus 13. Now, you have to compare the first term on the inside and then the first term on the outside. So, if you have 2x cubed, just divide it by x squared. This is how you can figure out what we need. Reduce that, we need 2x. Then we're just going to line out the x term, which is right here. I'm going to put down 2x. And we will take 2x times everything and then line them up right here. 2x times x squared is 2x cubed. 2x times 4x is plus 8x squared. This times this is plus 26x. And then for long division, we have to subtract. Put subtraction, parentheses, everything has to be subtracted from this. The first term though should always be cancelled. They are gone. Next, 9 minus 8 is just 1, and write down the x squared term. Next, 30 minus 26, which is plus 4. And then we bring down the plus 11. Now, x squared, of course, we just need 1, but you can always do this. Yeah? So we need plus 1, and then put plus 1 times all that is x squared plus 4x plus 13. Subtract everything. This is gone. This also happens to be gone. And 11 minus 13 is negative 2. That's it. We can come back to here and say we are just going to be integrating. The top is the quotient. It's just this. 2x plus 1. Reverse power rule for that. And then next though, we have the remainder here. This is the minus 2 over the original denominator. So let's write that down. And then of course we have the dx, and then let's go ahead and close that. And as you can see, originally we have this humongous integral, but right now, this right here is much more doable, right? Thanks to the polynomial long division. For more examples like this, check out the video in the description. Again, a lot of times in calculus, you have to remember your algebra. So let's go ahead. Integrating 2x, we just get x squared. Integrating 1, we just get x. But now how do we integrate this? In fact, we will have to do more algebra because on the bottom, notice this is not factorable with real numbers. This is the case that we will have to complete the square. So let me do it right here. CTS for x squared plus 4x. And we have the plus 13, so I'm just going to put the plus 13 right here. Leave a space right here. Now, what we need is we have to take half of this coefficient. Be sure that this is 1, which it is. So take half of this, and I'm just going to put it here. So half of 4. And then also square that. Now, this is 2 square, this is 4. So this is the number that we will have to add right here, but we have to make sure we are not changing the whole value of the expression. So I'm going to minus 4 right after. So this is the adding 0. And if you look at this, this is factorable. We get x plus 2 square, and then this right here is just plus 9. And that's how we complete the square for that. So if we look at this a little bit, this right here is just the integral, and perhaps I can put a negative 2 on the outside, and we just have 1 over. The bottom is this now, x plus 2 squared, and for the 9, I'm going to purposely write it as plus 3 squared, and then dx. Now, why though? How do we continue? Here is the formula that you have to remember. This one right here. So here's the formula, and notice I use u right here because right here we have x already, and here inside is x plus 2. if you do a super quick sub u to be x plus 2, then you can see that du is the same as dx. So it doesn't really change anything. So the integral of this is we have the negative 2 in the front, but the a value is 3. So we will have to divide it by 3. And then we have the inverse tangent of the u, which is just x plus 2, over the a value, which is 3. So that would be the integral for that. So we can come back here and say minus 2 over 3 times inverse tangent of x plus 2 over 3. Like this. That's it. We are all done. Put a plus C and box the answer.